for having me here. I hope you can hear me. I'm not big on microphones and stuff. So I don't know much about the Rotary Club. It seems I recognize some city people here, and maybe there are business people. I don't know. So climate change is really about managing risk in a time of uncertainty. A lot of the knowledge from business applies directly to this problem. I think the idea of business is you take risks and then you hopefully get some kind of reward for taking a risk. And books by Nassim Taleb, The Black Swan, The Impact of Unexpected Events, and so on, that whole machinery can be applied immediately to climate change. I also think some of the mottos of the Rotary Club, I forgot the 4 things that you have, telling the truth, etc. Is it helpful? Does it bring people together? All that stuff applies to climate change. We want to tell the truth about it. We want to take actions that are beneficial to everybody and so on. So I think there's overlap here. I'm not just trying to pander. I think this is fundamental, those 2 things. But anyway, so yeah, and the federal employees were asked this last week to say, what did they do the week before? And they had to give bullet points. So I was thinking, I'm not a federal employee, but what did I do last week? And I couldn't really think of anything. I sat at home and read books and things. I don't know. So, and I came across a book of poems by the great Greek poet Constantine Kabafi, who worked for the Office of Irrigation managing the Nile River about 100 years ago. And he lived in Egypt, and he was an acquaintance of my grandparents. But he wrote poems in his spare time. His official memos are forgotten, but his poems live on for 100 years later. And I came across a manuscript that fell out of this book. And amazingly, it was a poem written by him on the piece of paper. It was in Greek, so I didn't know, I couldn't read it, and I had it translated. I think it's relevant to the situation that we're in right now, so I'd like to share it with you. So it's called Things Changed. Engulfed by fear and suspicion, minds agitated, eyes alarmed, we desperately try to invent ways out, plan for the inevitable danger that threatens us so terribly. Yet we're mistaken. That's not the danger ahead. The news was wrong, or we didn't hear it, or we didn't get it right. Another disaster, one we never imagined, suddenly violently descends upon us, finding us unprepared. There's no time left. Sweeps us away. So I think I was told by Joe not to be political. Climate change, unfortunately, is a political issue. I won't be partisan. There's no partisan issues here, but I think certainly it's fair to say that people in America are worried. They're worried about different things. And so we're not all worried about the same things. And maybe there are things that we're not worrying about that should also be on the radar. But I'm not a poet, so to reassure you, I'm a scientist. And so from a science perspective, as Joe implied, my training's in astronomy, I have a PhD in astrophysics. From an astronomer's perspective, one can think of the Earth as a spaceship hurtling through space. Its passengers are anxious and fractious. The life support system is vulnerable to disruption and breakdown. But there's too little planning, too little horizon scanning, too little awareness of long-term risks. Long-term risks in my lifetime come in 2 categories. Those which haven't changed, maybe the risk of an earthquake, the risk of a lightning strike, something like that. And those which are changing rapidly, the risks of pandemics, bioterror, bioerror. I was just at a meeting yesterday at Silmar. My meeting was on managing water in the West, but in parallel there was a meeting, the 50th year of the meeting they had on recombinant DNA, which is precisely about that, managing bioterror and bioerror. And of course artificial intelligence, and the subject of this talk, climate change. So in order to manage these rapidly changing risks, we're going to have to compromise between 3 things that we value: our privacy, our freedom, and our security. The extent to which we're willing to do that is the extent to which we trust the government to take decisions on our behalf. But trust is granted, not taken. We give our trust to people for certain tasks. How should we decide who to trust and for what? I think the first thing to ask is whether the person or entity is trustworthy, meaning are they competent and honest and reliable? All 3 of those. Only then should we grant our trust. So where do we scientists fit into this picture with climate change? So I think it's important that decisions, we scientists have to be viewed as trustworthy by the government, because we're living in the age of climate change, and particularly water policy in the West, which is what I'm talking about a bit here. Motor cities embedded in a larger system. What happens in the larger system impacts us. So scientists have to be viewed as trustworthy to give information to policymakers and decision makers and managers. The decision has to be rooted in reliable science and then factor in political and economic factors. But there's a second important thing, which is what I'm doing here, to talk directly to the public, because it's important in our society that critical decisions be preceded by an informed public debate. And it's equally important that the public not be taken in by bad science. And so I think that's a dual function that we scientists have to play in society. So let me turn now to more directly to the border issues. I got a handout so you can look at some of this stuff in your own time. I think there's one aspect of this climate thing that's a story. So there's a story of the ancestral wetlands. So there's two big reservoirs, of course, in Colorado. There's Meade and then there's Powell. There's a tributary to Lake Powell, the San Juan River, about 200 miles it flows, and the northern San Juan, about 50 miles north, that whole area, had a civilization in the ancestral wetlands. They lived there for 600 years. They ebbed and flowed. We know how they got their food. Their buildings are still there, their sites. It's an incredibly amazing place. And then, after 600 years of living there, within 5 years, in the 13th century, everybody left. Motor City, what, 16,000 people? 30,000 people got up and left and never returned. I think there's a lesson there for us here in the West of vulnerability to political and climatic and those kind of shocks. Things don't go on forever, they can end. And so I think that's an important lesson from the ancestral prevalence. It's a more longer and more complex story, but I'm trying to keep it short. And so that's a little lesson in history. There's also a history for managing the Colorado River. So the Colorado River Compact was written about 100 years ago in November of 1922. And there were numbers put into the compact, legally binding agreements that did not correspond to what subsequently happened. That's sort of the root of the problem. And the standard story, which I want to give my own spin on, the standard story is that, well, it was wet and cold in the early 20th century, and therefore there was more water, and therefore they do it in these crazy units of acre feet, because it was farmers, so maybe 17, 18 million acre feet a year of water was available. And so that's the water that was divided up between the states. And subsequently it turned out to be more like 15 million acre feet for the 20th century, and for this century, 13 million acre feet. So the supply of water has been decreasing. But from a scientific point of view, what the story misses is that it's not the numbers that matter, it's the uncertainty. I think business people would understand this. It's not, because the fact is what they didn't factor in is that they didn't know the number. And when you do the math, which is maybe a little bit beyond, but you can calculate the uncertainty of the mean. It's not the mean, it's the uncertainty. You never cross a river that's 4 feet deep on average. If you got that joke, then you understand uncertainty. So that's where the risk is, in other words, in the uncertainty. So what we knew in 1922 is that the river flows lay somewhere between 13 million acre feet and 21 million acre feet. That's a gigantic uncertainty. Given the uncertainty at the time, 15 million is not at all surprising what happened. It's well in the middle of what was known at the time. And there's a little nod to USGS. There was one guy, Eugene LaRue, since the federal employees are getting hit on the head every day now, he actually got it right. He used a proxy, he used the elevation of the Great Salt Lake to push the gauge data back another 50 years to 1850. And using that as a sort of gauge beyond the measurements, he got a number of 15 million acre feet. So, but it's easy to look back and see who was right and who was wrong. I think the situation back then was uncertainty. So, and Colorado River usage today, since that's our supply of water, is 50% agriculture, 20% urban and industrial use, 10% reservoir evaporation, which isn't factored into these things, and 20% riparian vegetation. That's the situation we're in now. I should also do a nod to, Joe mentioned the concern with the Navajo Nation, to the Native American right to water. The Supreme Court said the Native American have a right to water. That's very nice. We're all happy. But they didn't specify who has to do what. Rights without responsibilities are meaningless. If no one has to do anything, I can say I have a right to this room. Does anyone have to do anything? Well, we don't know. We'll talk about that later. So as a tribute to them, I'd like to just read a couple of quotes from them. Here's the Southern Paiute. Southern Paiute people have known Big River Canyon and survived and prospered along the Colorado River since time immemorial. We know that the plants, animals, soils, and minerals of this land have their own self-willed life force. In talking to them, we receive guidance on how they wish to be treated. And the descendants of the ancestral pueblos that I refer to, among them are the Hopi people who are still here. They farmed very successfully on their Hopi, in the Hopi nation, in a place where Western scientists said it was impossible to grow corn. They did reconstruction, they said you can't do it. Well, they said, well, we've been doing it. So we have lessons to learn from them, how to survive in these borderline desert environments. Upon entering the fourth world, the Hopi people engaged in a spiritual pact with the earth guardian, Massaw, who instructed them to care for and cultivate the land. Massaw declared, you, all along there, make footprints, directing the Hopi people to leave behind footprints, material remains, as proof that they had vested the land with their stewardship and fulfilled their spiritual responsibilities. I just say this because natives are too often excluded in our society. They don't have a voice, so let's at least give them a voice. And I'm trying to do that in this work that I'm doing. So let me bring you a little bit to the science of the Colorado River. So the reason the uncertainty was so high in the 1920s is because we didn't have a lot of data. The uncertainty depends on the number of years for which you have data. So you can either wait a long time, and let's wait 200 years and we'll have better data, or you can go back into the past. And so with tree rings, actually, dendrochronology, which is an amazing science that was developed by an astronomer, actually, Douglas, about 100 years ago. You can go back 2,000 years and have records of river flows. And that's important because it tells us what the long-term average, what the water supply is long-term. Secondly, it tells us the fluctuations in the river flows, mega droughts, that river flows could decrease by 20% for periods of 50 years. That's in the past. That's what did in Chaco Canyon, if you've heard of that place. It's a huge city, and it collapsed. Everyone left in 1150. It coincides with a drought similar to the one that we're in today. And let me, you guys aren't scientists, I don't want to bombard you with graphs and data. Let's just get to the bottom line of what the science is telling us. This century, everything is trending in the wrong direction in the Colorado Basin. The temperatures are going up, and the stream flow is going down. That's the risk to Boulder City. Boulder City isn't a bubble isolated from what's happening. And if that's too complicated for you, just look at Lake Mead. You know, in our climate group page, we post a picture of Lake Mead. That's not complicated. You can see what's happening. That's an artificial thing because Lake Mead's level is determined by river management. There's a number of reservoirs upstream of it. But it gives you an indication of what's going on. As far as the precipitation is, it hasn't changed that much. So that's one thing that we know. So another thing we can do is try and model the river. We can use physics. We know the laws of the physics teacher over there. We know the laws of physics, and we can put all that into various big supercomputers and try and model things. It's very difficult because unlike it's not what happens in Vegas stays in Vegas. This is like more what happens in the Colorado Basin is influenced by things very far away. They're called teleconnections. So there may be storms off the east coast of Africa that travel across the Pacific and then manifest them as atmospheric rivers. So you need to model everything in detail, which is very difficult. I'm not here to do a sales pitch. The models don't work right now. So we're working on them, trying to fix them. One thing they can't explain is the aridification of the Colorado Basin. There's more humidity in the atmosphere in the models than we're seeing in the arid regions of the world. So science is, you know, provisional. We try and improve it all the time. And let's see. So yeah, just a couple of thoughts about that. Given this, how are we supposed to deal with all this? So the one thing is, yes, city managers and people need to understand that science is provisional. We do evidence-based reasoning, so we change our minds. That's not a bug in science, it's a feature. Because if the evidence changes, our opinions change. Secondly, I think in this age that we're living in, you need to bear in mind that the unfamiliar is not the same as the improbable. That's true in spades as we read the news every day. And lastly, the idea that in order to take a decision, we should concentrate on the consequences rather than the probabilities is a central idea of uncertainty. And that's why you probably wore a seatbelt when you drove here. You didn't know the probability of getting into a car wreck, but you knew the consequences. Of course, it's the law anyway. So let me just say a couple of words about the Polo City Climate Action Group as I wrap up. I hope I haven't spoken for too long. And so we have a number of things. What we're trying to do is to control, what can be done. Control is a big word. Suggest what should be done in the city where not a threat to anybody. There's really 4 of us who are very active. There's 300 of us on the Facebook page. And what we would like to see is reduction in water, particularly on golf courses. I think that's a place to start. That might be contentious. You don't have to agree with me, but that's what we think. So, because the water supply is, in this bigger picture, is not very reassuring what we see. So that's just our opinion. And I've listed it here, what we think should be done. So you can read it. And I came in a collaborative spirit. I hope we can help you guys out. If you do like the cleanups or something, our group's willing to go out there and join in and do something to help you guys. And if you think we have anything valid to say, please join us. We're all in the same boat. Everyone's in this together. And the science, I believe, is not really negotiable. It's not partisan. The atmosphere is just chemistry and physics and thermodynamics. But what I have said is controversial. Let's not beat about the bush. There are counter-arguments. So Boulder City climate action, the strong opposition to climate action. Let me mention these arguments just so at least I recognize them. So yes, climate change is real, but posing it an existential threat is alarming. Scientists like me are alarmed. Anyway, phasing out fossil fuel is too expensive. Human welfare depends on economic growth. If we cut down economic growth, the harm will be much worse than the harm to the environment from doing nothing. Technical innovation will save us. Scientists have made amazing inventions in the past. They'll come up with something that will sort this out. And we're resilient, so we can weather these storms one way or another. And lastly, it's not our fault, it's all India and China's fault. So you might say, well, what's India and China got to do with Boulder City? But it's exactly the same argument we make in Boulder City. We say it's not our fault, it's Vegas's fault. Nevada says it's California's fault. California says it's Arizona's fault. Every single entity that's involved in this blames somebody else. The lower basin says it's the upper basin's fault. It's all Colorado, Wyoming, and Utah. Utah says it's the lower basin's fault. And so I think these arguments, I acknowledge them, but I think they can be discussed. And that's pretty much my talk for today. So I think we can move forward. We're all in this together, and I came here in a spirit of collaboration. I hope this was at least informative and that we can work together. As I said, our group's certainly willing to put out the word on our page to join you in one of the community efforts. I certainly like your 4 points of telling the truth, etc. I can't remember, but trying to help other people and being generally good people. That's fundamental to what we try and do as scientists, particularly in climate change. And I certainly appreciate the opportunity to speak here. I think it's very generous of you. I think Joe took a risk. He didn't know what I was going to say. He's not responsible for what I said. And I appreciate you hearing me out. Thanks for having me, and that's my pleasure.
Question for you. I don't know you. I'm just curious what your background, where you come from, why you came to Boulder City. I mean, I think you have an idea where you.
Well, I see one of our regents here, so I came here because I got a job at the University of Nevada in Las Vegas. But I studied, was born in Switzerland, born and raised in Switzerland, and then I studied physics at Cambridge. My CV seems improbable to me for being a rather average, mediocre student. But I ended up at Cambridge University, surprisingly studied physics. Then I went to Leiden University, got a PhD in astronomy. If you've heard of the Oort cloud, I worked with one of the great scientists of the 20th century there. And then I went to New Mexico State, did a postdoc there. It all seems very unlikely. And And it was my goal, but you can create that. And then I ended up at UNLV. I didn't know what I was doing. I just was a researcher, and I was hired. And I got to really appreciate UNLV. I want to say that for the Regents, again, not because UNLV is about opportunity. And so I'm proud to work there because we give people opportunities. We don't guarantee there's no free ride or whatever. But I feel that's what we do there. You know, we teach, there's a lot of first generation people, and so I finally understood what it was about. And I'm proud that we do that. I think it's an important function. And yeah, I've taught in the physics and astronomy department for the last 30 years. We've built up a world-class program. Now I've turned into good commercials, but we have a speaker. I run a public lecture series because I do believe in doing outreach. And we have a speaker, the director of Palomar Observatory, is giving a public lecture tonight, and you're all invited. 7:30 p.m. down there. If you can't make it, we record these lectures. And it's Rhee is talking about the origin of the periodic table, the elements, the atoms that are in your body. How did they get there? They were created in stars. We're all brothers and sisters. We're all made out of. We all came from the same star explosion. So he's going to talk about these amazing discoveries. He reinvented Palomar Observatory. That's a long-winded story, but that's kind of who I am.
And so what brought you to Boulder City?
What brought me to Boulder City is I got a job at UNLV.
Okay.
And so, so why Boulder City? Because I like living there. It's quiet and peaceful. If you like reading books, and it's a nice place where you. I rented a place near campus, and then it was kind of noisy and scary, and I didn't like it. And so it's one of the worst zip codes in the U.S. I was told by some law enforcement guys. But I didn't. And so, and then actually I had a friend, a musician, Joe Cowell, who used to do a TV program on NPR. I wasn't expecting to tell my life story, but I came out for his birthday to go to Sydney, and I was like, oh, I like this place, and so I moved out here in '96, and then yeah, I've been happy here. It's been a really nice place to live in. Yes, sir.
Is it safe to say then that UNLV is a better school than UNR?
I would say no, it's not safe to say. Because the schools are not, I mean, it's not, they're not, I understand maybe from the public perception, but we're scholars, you know. There are idiots at UNR, there are idiots at UNLV, there are world-class people, I'm sorry to, world-class people at UNR and world-class people at UNLV. So I think, I'm a bit wary of metrics. We like to come summarize things. What happens with metrics is people, because that's usually, if you want to settle that debate, you look at the numbers. And then people start gaining the numbers. And then, and for a teacher, I think a grade should be a window, not a scoreboard. But they treat them as scoreboards. So they think, you know, like me as a teacher, I'm just trying to give a student feedback. I'm saying, here's my opinion, and then they get angry. It's just my opinion. It's not a judgment on you. So I'm a bit wary of that sort of metrics. I mean, I went to Cambridge University, which is rated as a top university in the world, I would say. And all of the prime ministers of the UK have come from Cambridge or Oxford. Most of them are bumbling idiots. They didn't know what they were doing. So I'm skeptical. Some of the dumbest people I know went to Harvard University. So I'm not very trustful. Just judge people on what they are and their abilities rather than their degrees, I would say. Or even whether they have a degree doesn't matter.
I've also heard people complain about India and China and the smog they have, and we used to have smog, we've cleaned it up, and now they have smog. Could you comment on the role that smog plays in global warming? I know that.
Yeah, so smog actually contributes to global cooling, so we should fire up a lot of coal plants if we want to counter, I'm being sarcastic, but so because smog is particles that reflect sunlight, and so there are people seriously talking about this. They call it geoengineering, where I'm not a big fan of that because typically experiments that we do on a large scale with the environment tend to go wrong. I can point to Australia where they brought in different species and then it went completely off the rails. Actually, I think China has cleaned up its smog, although they are opening coal plants, but they're also the leader in renewable energy there. And they're at the forefront of climate change because if the Himalayan glaciers go away, they're going to lose their water supply. But in terms of smog, yes, smog, in terms of physics, is actually a cooling agent. But of course, it's very bad for human beings. So we need to get rid of smog, I think, to have clean air is a good thing. I don't know.
One question for you.
Yeah.
I'd just like to get your take on hydroelectricity. I know the Snake River, some facilities on that system were recently at risk, and just kind of in the whole climate change narrative. What's your view on hydroelectricity, and if dams and hydroelectric facilities are kind of put at risk in this equation? What's your take on it?
Well, that's a big question. I mean, I have a whole, I'm trying to give a quick answer. I mean, obviously, you know better than me. I think Boulder City gets 50% of its electricity from hydro. I think, yeah, it's sort of a very complex problem. I mean, we depend on water, so we depend on the dams. So, and so what I think, well, for the hydro, so the hydro is the hydroelectricity is generated by the height through which the water falls, of course. So Hoover Dam's a giant waterfall. The water just falls and spins these turbines. And so there's the amount of water going through and the height. So obviously when the reservoir is lower, the electricity produced gets less. And so there's a vulnerability there. There's a vulnerability if the water drops below the level of the intake for the power turbines. Then we lose the electricity. Then there's another vulnerability if the water drops below the intakes for the dam entirely. Then you get no water through Grand Canyon. Actually, you get about 1,000 CFS of seepage because up at Lake Powell it's sandstone. I think there's a concern for me, so I shouldn't just crowbar all my opinions about hydros, but I think there's a vulnerability there. Yes. I think hydroelectricity is a good thing, and it fascinates me. I learned about it when I was a river guide in Grand Canyon, and I love the desert, so that's one plug I want to put in. Let's not, in Boulder City, sometimes we tend to think, well, the desert's a bad thing, it's not a nice place. It's an amazingly marvelous place. So my first trip down Grand Canyon, or one of my trips, we get to Lava Falls, the biggest rapid in North America. And the guide said, well, we've got to get up early to get to Lava Falls at 9 a.m. Why? We're in a wilderness, we're in Grand Canyon. Who cares when you get there? So it's Thursday, we need to get there so that we get Wednesday's water. What are you talking about with Wednesday's water? And so what happens, it was amazing, speaking of hydroelectricity, people in Los Angeles get up in the morning, they fire up their microwaves and their stuff, yet someone in Grand Canyon Dam turns up the water. There's a man-made tide that goes down Grand Canyon Dam. Nature's made at 5 miles an hour. So Lava Falls is 100 miles away from Glen Canyon Dam. At 5 miles an hour, it takes about 1 day. So when that tide that is launched around 7 a.m., if you want to catch it to get the left run at Lava, you want to get there early to get that 24-hour tide that has reached you. So it's fascinating how things are interconnected. That doesn't answer your question, but it's a little story.
Yeah, I told George I don't know if he has to get a medal, not like you would get from Cambridge. We appreciate you being here, and while talking about drought and the loss of, I guess, the Anasazi you're talking about to San Juan, that's not necessarily fun, but clearly you have fun in the work you do, and you mentioned the four-way test, and that's fun for us. So I want to make sure we have a fun leader. You can spread the fun around.
Absolutely, yeah. Thanks again. Thank you.
Before we move on, Tony, I need to point out that there's scientific and scholarly opinion that UNLV is not